Hello.
Good evening, sir.
Yeah.
Hello.
Good evening. So we'll continue with calculus. In the last class, we had looked at a little bit of introduction to limits, right?
Yes, sir.
Have you read anything about limits and all?
Sir, I read through H.C. Verma till derivatives that part.
So do you understand what limits means?
Yes, sir.
There is a y is equal to f of x function. X is equal to a. Now at x is equal to a, if you approach x from this side or from this side, right? If x becomes closer to a, closer and closer to a, what is the value of fx going to be, right?
Yes, sir.
So you will see that fx is approaching some value here, some value f of a or something, right? So that is the limiting value if from both sides you are approaching the same value. Okay? So if you say limit of x tends to a minus f of x is the same thing as limit of x tends to a plus f of x, and that is equal to some value L. If this is true, then we say that limit of x tends to a f of x is equal to L. What is the meaning of this a minus and a plus? Do you understand that?
Yes, sir. A minus means X is increasing and going to A, and A plus means it's decreasing and going to A.
So a plus means it is above a, slightly higher than a, and coming down to a, right?
Yes, sir.
So this is called left hand limit. This is called right hand limit. Both left hand limit and right hand limit must be equal. Then only you can say that the limit exists at this point. Okay? For example, we can draw the graph of a function like this. Let's say this is my graph of a function. This is 1, this is 0. This is y is equal to minus x, and this is y is equal to x plus 1. Okay?
Mm.
So the function is defined as f of x is equal to minus x for x less than equal to 0 and x plus 1 for x greater than 0. Okay.
Mm.
So this is my function. Now, obviously, if you think about limit of x tends to 0 f of x, what is the value of the function as you approach 0? But the problem here is that if you approach 0 from this side, you are getting closer and closer to 0, right?
Yes, sir.
But if you approach from this side, you are getting closer and closer to 1, right? So here we will say limit of x tends to 0 minus f of x is 0, but limit of x tends to 0 plus f of x is 1. Correct?
Yes, sir.
You can see that from the graph of the function itself, right?
Yes, sir.
So this is LHL, this is RHL, and both are not equal to each other. LHL is not equal to RHL. So we'll say that limit of x tends to 0 f of x does not exist. I hope you are understanding what I'm saying.
Yes, sir.
From both the sides, you have to approach the same value, then you say that limit exists. Okay.
Yes, sir.
Now, in 12th grade, when you do the limits chapter, there will be many techniques of finding the limits of different type of functions. Right now, we will not do those techniques because mostly we will not be using that so much. But in general, you will have to say find the limit when x tends to 2, x minus 2 by x square minus 4, right? This is a situation. You cannot put 2 directly in it because it will become 0 by 0, right?
Yes.
However, if you cancel one factor, you can see that x minus 2 is a factor, so it can be written as x plus 2, right?
Mm.
In that case, now we can put the 2 value, right?
Yes, sir.
The limit is actually 1 by 4. So after cancellation of a factor, you are able to calculate the limit, right?
Yes.
So that is one technique. If you cannot directly put the value of the limit, then you should think about how you can change the function a little bit by maybe cancelling some factors. There are other ways by rationalizing and so on. But those techniques for finding limits are not super important right now. However, one limit is important. This is the limit. Limit x tends to 0, sine of x by x, and also this limit. Limit x tends to 0, tan of x by x. Like this is my function. And what is the value of the function as x tends to 0, right?
Mm.
Now in this case, you can see that directly you cannot put 0, no?
Yes.
Because the denominator is 0, it doesn't make sense, right?
Mm.
However, these two limits are super important, so I'll show you how to get the limit. The answer for both the limits is 1. Both the limiting values are going to be equal to 1. Okay.
Mm.
1 second, hold on. There's someone at the door. 1 second. Okay. Can you hear me?
Yes, sir.
So what we will do is we'll learn how these two limits are going to be equal to 1. Okay. So in order to understand this, we'll do a geometric proof. And for the proof, we are drawing a circle. And this circle, okay, I'll do it on the next page. So this is my circle. And this circle has radius is equal to 1. Okay. Now,
Mm.
what we need to show is limit of x tends to 0 sine x by x is equal to limit of x tends to 0 tan x by x is equal to 1. This is what I want to prove. Now, what we will do here is take a point P here, and let's say P moves on the circle like this, goes to Q. Okay. So we'll connect OQ and OP. And obviously the radius is 1. So OQ length is equal to 1. OP length is also 1, right?
Yes.
And let's say this angle is theta. Okay. Or we can
Mm.
call this angle as x also. Let's call the angle as x. Now, if you think about it, what is the length of this arc?
Sir, x into r.
Length of the arc
Sir.
is r into theta, right?
Yes, sir.
So radius is 1 and x is the angle. And here you have to remember the angle x has to be written in radians, right?
Yes, sir.
Radians means the unit where you write it in terms of pi and stuff, right?
Yes, sir.
Do you know the conversion between degrees and radians?
Yes, sir.
Pi radian is 180 degrees. So basically the full 2 pi radian is going to be 360 degrees, right? Correct?
Yes, sir.
Arc length
Yes, sir.
PQ is equal to 1 into x. However, what we need is something slightly different. So what I will do is I will first join P and Q with a straight line, which is a chord. P and Q have joined like this. And I have extended this a little bit like this. And from P, I draw a perpendicular which cuts here, R. What is special? This line
Mm.
RP is perpendicular. RP is perpendicular to OP. Okay.
Okay.
So now you have three things here. You have triangle OQP. Can you see the triangle OQP?
Yes, sir.
This is the side QP, and these are OQ and OP are the other sides, right? You
Yes, sir.
also have a sector OQP. Can you see the sector?
Okay.
So
Yes, sir.
forget about the triangle line. Think of the whole circle, the sector, the part of it, right?
Mm.
And you also have a triangle ORP, right?
Yes, sir.
So in this figure now, let's try to think of the area of triangle OQP. Area triangle OQP is a triangle like this, and this is one, and this angle is X, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
So what is the area of this triangle? Can you tell me an expression for the area of the triangle?
Uh, Sir, you can find the area using Heron's formula. So under root of
Oh, Heron's formula you cannot find because you don't know the third side, right?
yes. Sir, you can take
Heron's,
it as QP. So you can just take it as QP.
oh, that will be super horrible. I don't want to use Heron's formula with an unknown thing. It's an unknown. What are the things we know in this triangle? We know 1, and angle X. Why don't you take advantage of this angle that is known? Area of a triangle is half base into height, right?
Yes, sir.
Can we find the height here? Height H.
Yes, sir. It is mm, uh, cos of x by 2.
Why are you saying X by 2?
Sir, sir, sorry, sir. Cos of yes, sir, sorry, sin of x. That is sin of x, sorry. So I took the height the other way, like one other height. It's okay. Sin of x.
Sine of X is equal to what? H by 1, right?
Hmm.
Do you understand that?
Yes, sir.
So H is equal to what? Sine of X.
Hmm.
So therefore, area of the triangle will be half into base into height. So half into 1 into height, right?
Yes, sir.
Base is my OP, right?
Yes, sir.
Area is half into sine X. Do you understand?
Yes, sir.
Okay, now tell me area of sector OQP.
Sir, x by 2 pi into area of circle, which is 2 pi r square, or
So
x by
this,
2.
right? Correct. This is coming, right? Area of sector.
Yes, sir.
Similarly, area of triangle ORP. Now think of the triangle ORP.
Hmm.
That is a right angle triangle, as you can see, right?
Yes, sir.
So we just need this height, right?
Yes, sir.
We already know this much is 1.
Hmm. So
So,
extend it.
so think
Tan
about
x,
it.
tan
Tan
x.
X is equal to RP by 1, right?
Yes.
Therefore, RP is equal to tan X.
Hmm.
So area of the triangle is half into 1 into tan X, right?
Yes, sir.
So basically you are getting tan X by 2, correct?
Yes, sir.
Now looking at the figure, it is very obvious to say that area of the triangle OPQ is less than area sector OPQ is less than area triangle ORQ. Isn't that obvious?
Sir, ORP, right?
ORP, yes. Is that clear? Is that obvious to you?
Yes, sir.
Because clearly from the figure, the biggest area is this, and the middle area is this, and the smallest area is this, right?
Yes, sir.
So therefore, what are we getting? We are getting sine x by 2 is less than x by 2 is less than tan x by 2, right?
Yes, sir.
Now think about a situation where the angle x is made close to 0. Angle x is being reduced and reduced close to 0, right? Now, like first, before thinking about that, you can think if the angle is made bigger, don't you see that the difference in the areas is becoming more?
Yes, sir.
Can you see that? Imagine that.
Yes, sir.
But if the angle was made smaller and smaller, you will realize that the difference in areas of this and this and this will become smaller and smaller, right?
Yes, sir.
So what we can say is that if x tends to 0, you can write area triangle OPQ is less than equal to area sector OPQ is less than equal to area triangle ORP. This equal to sign is coming only if the angle is becoming really close to 0, right?
Yes, sir.
Because all the three things will start coinciding. Like if you think about it, if the thing was here only, you can see that the sector and the chord area, triangle area are so close, right?
Yes, sir.
So in the limiting case, limit x tends to 0, you can say that in that case, sine x by 2 is almost similar to x by 2 is almost similar to tan x by 2. Right?
Yes, sir.
So in general, what we have is sine x by 2 is less than x by 2, less than tan x by 2. So if you multiply by 2, it gets cancelled. You have sine x is less than tan x. And you divide everything by x, you get sine x by x is less than 1 is less than tan x by x, right?
Yes, sir.
This thing is true in general, but if limit x tends to 0, then all three ratios become equal, right? Because
Yes,
all the three areas will start approaching each other.
yes, sir.
The only difference between this ratio and this ratio, both of them will approach each other, but the difference is that this one approaches 1 from less than 1. So it will approach from 0.99, 0.999 and so on, right?
Yes, sir.
And this ratio tan x by x will approach also 1, but from bigger values than 1, right?
Yes, sir.
So for an angle x that is not 0 but like close to 0, you should get sine x by x should be not exactly 1 but close to 1 but from lesser than it. So something like 0.99 and all. And tan x by x would be not exactly 1 but close to 1 but something above it, right? And as you make x closer and closer to 0, both of these will tend towards one common value which is 1. Do you understand?
Yes, sir.
So that is a geometrical proof of why this limit is 1. Sin x by x is equal to limit x tends to 0 tan x by x. And in that is also 1. Right? This is a super important result. In many places in physics in the future, you will see that whenever you have a sine of some theta and somebody told you that theta is close to 0, right? Or theta is small. In that case, you can always replace sine theta with simply theta. Similarly, you can also replace tan theta with simply theta in that case. Why? Because the limit here is 1. Are you understanding?
Yes, sir.
We cannot do this if the theta angle is bigger than, not close to 0. If it is like 8 degrees, we cannot do this. It has to be close to 0, small. Okay.
Yes, sir.
The reason I did this derivation is because when we discuss the next concept and when we do derivatives, you will need this limit in order to derive some of the results that we will see. So now we'll talk about derivatives. Basically, a derivative is it describes the rate of change of a function. Rate of change of a function with respect to the variable x, let's say. Obviously, a derivative could be with respect to any variable. So if you have y is a function of x, what is the meaning of dy by dx? Dy by dx is the same thing as rate of change of y with respect to x. And what does that mean? That means how fast is y changing when you change x by a little bit, right?
Yes, sir.
So generally, the way we define it is, what is the change in y divided by the change in x? This is the definition of an average rate of change of y, right?
Yes,
For
sir.
example, when we talked about average speed and instantaneous speed, average speed would have been total change in distance by total change in time. But that is not an instantaneous rate. And when we talk about derivatives, that is an instantaneous rate of change of a function. So we also have to say here limit of delta x should tend to 0. What is the meaning of this? This means that you have to change delta x by a really small amount, right? If you change your delta x by a really small amount and then measure how much change in delta y happened, then that ratio of delta y by delta x will give you the derivative.
Yes, sir.
I hope you are understanding what I'm saying.
Yes, sir.
We are actually calculating average rate of change, but we are taking limit as delta x tends to 0 of that average rate of change. Or in case of speed, we are doing limit of delta t tends to 0, total distance by total time. So we are saying it is the average speed, but only for a really small time interval, which is almost like a 0 time interval, right?
Yes, sir.
So that will start looking like an instantaneous speed, right? Speed at the current moment.
Yes,
Correct?
sir.
Now,
Yes.
the idea is the way this derivative is defined is in this fashion. So let's say we have y is equal to f of x. Now we'll say I want the derivative of the function at this point. X is equal to a, let's say, right? So I want how fast, when I say I want derivative dy by dx at x is equal to a. This is my question, right? So what does this mean? This means how fast is the function, is the y changing if you change x by a small amount when x is equal to a, when x is close to a, right? So if you are close to a and if you change x by a small amount, how much did the y change, right?
Yes.
So the meaning of this is pretty simple. You will say, I will take one point here and I will take a nearby point here. Let's say this point is x is equal to a plus h, okay? This h is supposed to be really small so that it's a really nearby point. Do you understand?
Yes, sir.
And then at x is equal to a, the function will have a value here, y will be equal to f of a, right?
Yes, sir.
And at x is equal to a plus h, the function will have a value here, y will be equal to f of a plus h, right?
Yes, sir.
What we have to do is find the difference in the values in y, the delta y, right?
Hmm.
And divide it by the difference in values in x, right?
Yes, sir.
If you calculate delta y by delta x, it will be, delta means a change in y. Okay?
Yes.
What is the change in y? It is f of a plus h minus f of a, right?
Yeah.
What is the change in x? X was changed from a to a plus h, right?
Hmm.
Whenever I write a delta something, I mean the change in that something. And change is always calculated by doing final minus initial. Okay?
Yes, sir.
Delta of anything is going to be r final minus r initial. Okay?
Yes, sir.
So this ratio actually gives us the average rate of change of the function. Change of the function when x changes from a to a plus h, right?
Hmm.
Are you understanding what I'm saying?
Yes, sir.
This ratio is telling us how much is the function changing, average rate of change of the function, if you change the x value from a to a plus h, right?
Yes.
But that is an average rate of change. What I want is a instantaneous rate of change, right?
Yes, sir.
So what I have to do is limit of delta x tends to 0 in this expression, right?
Yes, sir.
So delta x actually was what? Delta x is actually simply h, right?
Hmm.
So we can say limit of h tends to 0 and write this expression. It is f of a plus h minus f of a divided by h, right?
Hmm.
This is the definition of the derivative at a. This is another way to write a derivative f dash a or dy by dx at x is equal to a. That's the same thing as this. It's the same. It's just two different ways of writing. Okay?
Hmm. Yes, sir.
So in general, whenever you have a function, what you will say is find y is equal to x squared, let's say was my function, right?
Hmm.
Question is find the dy by dx of this function, right?
Hmm.
So what we are doing actually is we are dy by dx means limit of h tends to 0, f of x plus h minus f of x by x plus h minus x.
Yes.
So basically I'm taking h should be really small and it is the ratio of change in y by change in x, right?
Hmm.
So this is going to be f of x plus h minus f of x and x plus h minus x becomes h, right?
Yes.
Think of this as the actual definition of derivative or dy by dx. The derivative of the function, any function, is defined like this. Limit of h tends to 0, f of x plus h minus f of x by h. Okay?
Yes, sir.
And so far what we have seen is the understanding of why we are defining it in this way. Because we are saying if your x values changes from here to here, the y values must have changed from here to here. We are taking the ratio of the change in y by change in x. Also keeping in mind that the change in x has to be really small.
Yes, sir.
If the change in x is big, it is not an instantaneous rate of change, it's an average rate of change, right?
Yes, sir.
So once you are getting this ratio delta y by delta x, you have to take limit of h tends to 0. In case your x was changing from x to x plus h.
Hmm.
I hope you're understanding.
Yes, sir.
So now what we can do is we can apply the same principle and find the derivative of our function y is equal to x squared. So we can say y is equal to x squared is my function. Dy by dx is defined to be f of x plus h minus f of x by h and limit of h tends to 0, right?
Yes, sir.
So what is f of x plus h? This is my function, so it will be x plus h whole square, right? Minus x squared by h, and we have to do limit of h tends to 0, right?
Yes.
Notice that you cannot directly put h is equal to 0 in this, right?
Yes.
Because the denominator has an h, you cannot put 0 for that, correct? So what we will
Yes.
do is we'll simplify it a little bit. We'll say this is limit of h tends to 0. The top part will be x squared plus h squared plus 2hx minus x squared whole divided by h, right?
Yes.
X squared gets cancelled and you have h squared plus 2hx by h, limit of h tends to 0. And h also gets cancelled and you have h plus 2x, right? Correct?
Yes.
And now you can notice that you can easily put h tends to 0 in this expression because there is no denominator becoming 0 now, right?
Yes, sir.
When you put h tends to 0 here, the answer is 2x, right?
Yes, sir.
So the derivative of x square is coming as 2x. Okay.
Yes, sir.
There is another way to think about the derivative. You can also think about the derivative as if you take 2 points P and Q on the curve, this point is x is equal, this point is x comma f of x, and this point is x plus h comma f of x plus h, right?
Yes.
If you join the two points by a chord line or a secant line, you can see that this line has a slope, right?
Yes.
Do you know about slope of a line from 10th grade?
Yes, sir. It's tan theta.
What is theta there?
So the theta is the angle formed with the horizontal.
So slope is tan theta, or you can think of it as a total change in y by total change in x, right?
Yes, sir.
Notice that for slope also you would have done something like this. You would have calculated the change in y here divided by the change in x, which is equal to tan theta, right?
Yes.
So notice that slope of the line was f of x plus h minus f of x, because the height here is f of x plus h and here it is f of x, right?
Yes.
Divided by the base. Base is going to be x plus h minus x, right?
Yes, sir.
So notice that the slope of the line is coming out to be the same expression, no? This familiar expression is coming, right?
Yes.
Now, this is the slope of the line joining the 2 points which are not so close to each other. They are far away and you have a clear line there between them, right? However, if you think about it, if Q is brought closer and closer to P and Q is here only, right?
Yes.
If Q is brought closer and closer to P, basically you are saying H is tending to 0, right? So don't you think that the line joining them is going to start looking like more or less the tangent line?
Yes, sir.
Tangent at P, right? Because Q itself is coming here, coming closer and closer to P, right?
Yes, sir.
So the line joining them is no longer a secant line. It starts becoming closer and closer to the tangent line, right?
Yes, sir.
So that's why in this expression stands for the relative or average rate of change of the function from P to Q. If you put limit h tends to 0 there in this expression, f of x plus h minus f of x by h, right? Then that is no longer an average rate of change because you have made the h really close to 0, correct?
Yes.
That is your definition of a derivative. And notice that we have written it in so many ways. We have written it like f dash x, dy by dx, the limit method, right?
Hmm.
Are you understanding what a derivative is?
Yes, sir.
What you read in HCV and now what you have heard, is it clear, the concept of a derivative?
Yes, sir.
Okay. So once you find the slope of this line and take the limit of it, it becomes the derivative, and you can also call this as the value of the derivative is the slope of the tangent at P. Why is it the slope of the tangent? Because earlier it was slope of this line. No? This was the average rate of change.
Yes.
That line has shrunk and become a line like the tangent, but the ratio is still the slope, right?
Yes, sir.
Are you understanding?
Yes, sir.
Is there any confusion or any doubt about the meaning of a derivative?
So no doubt.
Okay. So now we will see some reasons for why we derived the, if you see limit of x tends to 0, we derived sin x by x is equal to tan x by x is equal to 1, right?
Yes, sir.
The reason I did that derivation is because now I want to show that dy by dx is equal to cos x if y is equal to sin x.
Hmm.
So if you notice in HCV there is a small table which carries a few derivatives value.
Yes, sir.
If there is a function, it has given us the derivative of that function.
Yes, sir.
So given y is equal to sin x as my function, I want to find its derivative. Okay.
Hmm.
There is no real way to find derivative except by following the definition. So definition of a derivative was limit h tends to 0, f of x plus h minus f of x by h, right?
Yes.
And f of x in our case is now sin of x, right?
Yes.
So this becomes limit h tends to 0. F of x plus h becomes what? Sin of x plus h. And minus f of x becomes sin of x. And whole thing is divided by h, right?
Yes.
Now in trigonometry in 11th and 12th, you will learn about this thing, the formula for sine of c minus sine of d, how to simplify it as a factor. So if you have two sines or two cosines adding together or being subtracted, then you can always write them as factors and products of things. So for example here, sin c minus sin d can be written as 2 sin c minus d by 2 cos c plus d by 2. Okay.
Yes, sir.
This is a trigonometric formula. Don't worry about it if you have not seen it before. We will do the proof of this formula soon when we learn a little more of trigonometry. Okay.
Yes, sir.
So right now you don't need to worry about the formula, how it came. We will do it anyway. What you have to see is what is the impact of this formula? How does it help us calculate the derivative, right?
Hmm.
So notice that if my function is sine, I have this situation of sine of something minus sine of something, right?
Yes, sir.
So what I will say is this is equal to limit of h tends to 0, sin c minus sin d according to this formula. I will get 2 times sine of this minus this by 2, right?
Hmm.
So that will be h by 2 if you think about it.
Yes.
And cos of this plus this, that becomes 2x plus h by 2. That becomes cos of x plus h by 2, right?
Yes.
So this is my situation right now. Whole thing is divided by h, right? You basically have an expression like this. Limit of h tends to 0, 2 sine h by 2 cos of x plus h by 2 whole divided by h, right?
Yes.
Now think about it. I can still not put h is equal to 0 in this equation, right?
Yes.
Because it is in the denominator. But what I can do is I can bring the 2 from top and write it here in the bottom by saying it is h by 2, right?
Yes.
So notice what is happening. Limit of h tends to 0. Sine of h by 2 by h by 2 and cos of x plus h by 2. This is what I have, right?
Yes.
And remember the limit that we had derived, that x tends to 0, sin x by x is equal to 1, right?
Yes.
So notice here that h is tending to 0. So obviously h by 2 is also tending to 0, right?
Yes.
And if h by 2 is tending to 0, then in the denominator also it is tending to 0.
Yes.
So notice that both the angles here and here are identical. It's not like here this was h by 2 and here it is 3h by 2.
Yes.
In this limit, the angles must match, right?
Yes.
And also x should tend to 0.
Yes.
So this is the situation where the angles are tending to 0 and both the angles are matching, and it is the ratio of sine of h by 2 by h by 2, right?
Yes, sir.
So this limit should be 1, no? According to what we saw earlier.
Yes, sir.
So overall this limit is 1, and when you try to find out this limit, you just have to put h is equal to 0 here. You will get a cos of x here.
Hmm.
So finally dy by dx is equal to cos of x, right?
Yes.
Now this formula has been given to you without proof, but I hope you have understood what is happening in this proof.
Yes, sir.
We are following the definition of the derivative. The derivative definition is, it means that rate of change of the function at a certain point, and what we are doing here is limit h tends to 0, and what is the rate of change of the function with respect to x, right?
Yes, sir.
Okay. Similarly, I can also prove the derivative formula for cos x. If you see in the book, they have given a formula for minus sin x for this, right?
Hmm.
So they will give you several formulas. What I want you to understand is that all of this is obvious if you follow the definition of the derivative and apply this limit concept. So limit of h tends to 0, f of x plus h. Now, if you think about it, now my function is cos x. So it will be cos of x plus h minus cos of x whole divided by h, and limit h tends to 0, right?
Hmm.
Now we have a cos c minus cos d situation, which will become 2 cos. This is again a formula that you might not be aware of. Cos c minus cos d. Is anybody, do you know this formula? Have you seen this?
Yes, sir.
You have seen it.
Yes, sir.
What is it?
Sir, it's minus 2 sine c plus d by 2 into sine c minus d by 2.
I have written sine d minus c by 2 because I don't want to put a minus 2 in front.
Hmm.
And we know that sine, you should know the sine of minus theta is minus sine theta. And if you
Yes.
don't know that, we will do the derivation and everything soon. So don't worry about it. However, in this case, we are getting, notice when I apply this formula to this situation, I will get limit of h tends to 0, cos of this minus cos this is, so 2 sine this plus this by 2, so x plus h by 2, and sine d minus c by 2, this minus this, so minus h by 2 by h, right? So this becomes sine of x plus h by 2 minus sine of h by 2 by h by 2, right?
Yes.
Do you see how I'm getting h by 2 in the denominator?
Yes, sir.
I have brought this down and I have kept this as it is, and I have written sine of minus theta as minus sine theta, right?
Yes.
And here we can see that as h tends to 0, this part will tend to 1 just like previous case, right?
Yes.
Why is it tending to 1? Because we already know that sin x by x is 1 if x is small, right?
Hmm.
And here it is sine of h by 2 by h by 2, where h by 2 is obviously small.
Hmm.
So it is tending to 1, and you're getting, if you put it in the other term, you'll get h is 0 here, you'll get a minus sine x plus, right?
Yes, sir.
So the point is the table of derivatives. How is that table made? Y is equal to x power n, the dy by dx is equal to n times x power n minus 1, right?
Yes.
We have already seen a proof of that for y is equal to x square. Dy by dx came out to be 2x, right?
Yes.
And this, if you recall, this did not come by memorization. The method to remember it is not memorization. We actually did the derivation, right? It is basically this minus this by this, right?
Yes, sir.
I hope you are understanding.
Yes, sir.
Now, similarly, you can prove that if y is equal to x plus n, you have x plus h power n minus x power n divided by h, limit of h tends to 0, right?
Hmm.
That is the method to get the derivative of x power n. It turns out it will become n into x power n minus 1.
Hmm.
So what I want to tell you is all the formulas in that table are derived by the same method. The method is the method that we have seen so far, how to understand derivatives. Basically, by taking the limit and seeing if that limit is giving us some answer or not, right?
Yes, sir.
There will be 4, 5, 6 formulas in that table. You need to go through them. Right. We can do the proof of each of those formulas, but there will be nothing new in each proof. Each proof will be a limit calculation.
Hmm.
Use the definition of derivative to just say that let's apply the definition of derivative to any of those functions and it will give us this.
Yes, sir.
Correct? Okay. So what we will do is once you know the derivative rules, I mean, right now you only know the derivative table of some of the values like y is equal to e power x, dy by dx is equal to also e power x, right?
Yes.
If y is equal to x power n, dy by dx is equal to n x power n minus 1.
Yes.
Similarly, there is y is equal to tan x, then dy by dx is equal to
Secant square x.
secant square x, yeah. And now you might wonder how come we are getting this formula. The same way we got the sin x and cos x derivatives. Actual method is finding the limits. Okay.
Yes, sir.
However, in the exam or in normal work, when you're preparing, it is not like every time you will have to do the whole derivation for every time you need a derivative, right?
Yes.
You can't do it. So therefore, we have some shortcut tips and some basic formulas that we must remember so that we can directly tell the derivative and instead of worrying about it, right?
Yes, sir.
So all of the formulas listed in the table in HCV need to be remembered. It will come easily once you do many questions, so that after that it will feel easier.
Hmm.
And we will also learn some rules. So far I have not told you about product rule for differentiation. Product rule, we also have to do chain rule. These two things we have to do right now. And then we have to go on to integration. So three things because we also have to do maximum minimum. Right?
Hmm. Yes,
Okay.
sir.
So After we do maxima, minima, we will go to integral calculus, which will be the fourth topic. So first we have to do these basic rules, product rule, chain rule, and so on. We'll understand what all that is, and then we'll move on to the next set of topics. Okay.
Yes, sir.
So if you are a little confused or you need more practice, you should check out your perhaps NCERT 11th book has a limit chapter.
Hmm.
Maybe it also has a derivatives chapter, limits, derivatives, and all.
It's given as one chapter.
So you need to go through that NCERT 11th grade limits and derivatives chapter. Okay?
Yes, sir.
If you go through that, you will realize that it's all the same thing that we have discussed in today's class. And every time you have to learn how to do it by the normal method, which is the limit method, or you have to basically learn how to do it by following the rules of differentiation, and all, right?
Yes, sir.
So go through that and go through the NCERT 11th chapter also. In the next class, I want you to ask me doubts. Okay, how do I differentiate this? You need to go through the chapter so that you have some doubts. Okay?
Yes, sir.
We are not moving to integral calculus today. We will do it after one class or so. And after integral calculus, we have to do vectors.
Hmm.
Once we finish vectors, then will we start our next thing. Okay.
Hmm.
So eventually, I want to finish integrals, vectors, basic stuff, and then go to your other parts of calculus.
Hmm.
So study this 11th chapter, 11th grade NCERT book a little bit. See if you are able to understand. And that's all I think for now. We'll need one or two classes to finish the whole differential calculus part of it. If you
Yes,
have any doubts, ask me. Any questions, any problems.
sir. No doubts.
Okay then. We will
Thank
do the next class on Wednesday. Read it by then and see 11th chapter book also a little and see it. Okay.
Yes, sir.
We'll do the next class on Wednesday to try to finish the whole derivative discussion.
Yes, sir.
Fine. That's all for now then.
Thank you, sir.